And you may now use a calculator, but as we go through this, I will show you why you still need to know the rules for this. You need to be able to do it yourself because you got to show your work. You will not get really any marks if all you do is put the answer on the test for fractions. There's a reason why we want to understand what we're doing before we allow technology to do it for us. For one, it's just, I mean, it's important that people know how to work with fractions, and you'll find when you get into grade 11 and grade 12, we need to know the fraction rules to do things that our calculator can't do. But also, it can catch mistakes. You might punch something into your calculator wrong and get a strange answer and go, that can't be right. That's another reason. And as I've said before, to be able to understand patterns and follow the math, that kind of thing, it's really important that we know how to do this. We don't just let our calculators do it. What you are going to be allowed to use your calculator for is like if you have a big multiplication that you can't do in your head, like 17 times 6 or something like that. Okay, you might get a question like that involves a fraction, so you can use your calculator to make sure that's right. If you have a really good calculator that can do fractions, you could use it to check your work. It won't necessarily find your mistakes, but it'll tell you that there's a mistake somewhere in your work. And again, on a quiz or a test, if you have time, you could try to go back and find the mistake. But down the road, when you're doing fractions, if you struggle with this and you can't do it in your head, then there will be a time where you can use your calculator to do fractions. So I said this before, it's a good idea now in grade 9 to get a really good calculator. I was talking to a couple of you yesterday, and you've got one a lot like mine. That's fantastic. Strongly recommend getting a good calculator. You will need it'll make your life a lot easier to get a good 2-line scientific calculator that you get used to and you understand how it works for all of high school and probably whatever you do in college, university. All right, let's get into this so we don't run out of time. Multiplying, this is what I said, multiplying rational numbers or multiplying fractions is easy. Well, easier than the other operations that we do with fractions. It doesn't always mean it's easy. It's not going to be easy for everybody. It'll be trickier when we put them all together and we do multiplying, dividing, adding, subtracting all at the same time and doing BEDMAS. Then we start to mix up the rules between them because the rules are different for each operation. But multiplying is the easy one. All you do is multiply straight across. Do not get a common denominator. Next week, we'll talk about adding and subtracting fractions. That's when you need a common denominator. Unfortunately, some of you will then go and start getting common denominators when you're multiplying. But try to remember, we multiplied first, we never got a common denominator. Technically speaking, if you get a common denominator when you multiply, you still could get the right answer. But man, oh man, you're going to make your life hard because your numbers are going to be so big, getting it into lowest terms is going to be really tricky. So try to remember, when you're multiplying, same is true when you're dividing, you do not need a common denominator. Couple of little notes. Be careful of signs. We're talking integers, we're talking negatives, right? So we got to watch for signs. As always, it can be a little bit harder when you have fractions. You're watching your positives and negatives. Second note, you must convert any mixed numbers to improper fractions. That's going to be our first step before we do anything else. Listen to me carefully. This is why in high school we don't like mixed numbers, in math class at least. Other classes they like them, but in math class we don't, because we can't do adding, subtracting, multiplying, and dividing not easily with mixed numbers. It's way easier with an improper fraction, and that's how we get to know the rules, and that's what other things later on in other grades are like. So we just get rid of mixed fractions. We never put our answers back into mixed fractions. We just leave them as improper fractions. That's what we like because that's what's easier to work with. And then for now, again, down the road, you have to just follow instructions. But for now, we're going to leave all our answers as fractions and always in lowest terms. Usually, the test or question or the homework or learning goal will say put all answers in lowest terms, but even if it doesn't, you have to. We always, as a habit, put our answers in lowest terms. Does that make sense? Sometimes we want an answer as a decimal, like if a question works out to how many kilometers you ran, you probably don't want that as a fraction. It would be weird to say 17 over 4 kilometers. Why would you say that? You'd say 4.25. That's what that would work out to, right? So you'd say 4.25 kilometers. That makes more sense to us. So if it's a word problem of some kind, you'd probably answer as a decimal. But for now, we're going to leave as fractions, and we're going to put them in lowest terms. Okay, so evaluate. Very first question. Again, you want to write down the question, the whole thing properly. This is -3 over 8 times -4 over 5. What's the difference between, before we get to this, what's the difference between -3 over 8 or -3 over 8 or, I guess, 3 over -8? Pardon?
Just for the first one, just the 3 is negative. For the second, the whole fraction is negative. And then for the third, just the 8 is negative.
That's what it looks like. What else do you think? And that, in some cases, is kind of true. You might say there's actually no real difference. There's maybe some reason why the 3 on top is negative, but from a number perspective, none of these are different. They're actually the same number. This one's fine, this one's fine, this one's no good. We don't like negatives in the denominator, in particular because adding, subtracting is going to complicate things. So if you have it in the denominator, you'd rewrite it just out front like that. Sometimes even if you have it in the numerator, that's the top part of a fraction, right? We didn't really talk about terminology yesterday. The numerator is the top part of a fraction. The denominator is the bottom part of a fraction. I'll use both terms. I'll sometimes call it the top and the bottom, but we also will use numerator and denominator a lot, so you need to know those words. So sometimes if we have it, we'll rewrite it like that. Sometimes we won't. It's okay to leave a negative in the numerator, not in the denominator. Okay, so in this case, I can think of this as a negative and this as a negative, and when you're multiplying, 2 negatives makes a positive. Very good. So same rule applies with fractions and rational numbers. The result will be a positive. And the answer, I'm only going to show this step one time. The way you multiply fractions is you multiply the top. So this is going to be 3 times 4, and it's -3, but I already dealt with the negative, so I said actually, let's include it. Why not? Well, no, I'm not going to. I'm going to leave it out because that one's going to complicate things. So I know the answer is going to be positive because I have 2 negatives. It's 3 times 4 over 8 times 5. So 3 times, yep. Oh, sure. So 3 times 4 is 12. 8 times 5 is 40. And we're done. Oh, lowest terms, right. How many people forgot already that we have to put in lowest terms? Can you reduce this? How, and we talked about this yesterday, but how do you reduce a fraction? You look for what we call a common factor, or a number that divides into both. What divides? And it's best if you can find the biggest so you can do it all in one step. But if you miss it, you do it again in the next step. What were you thinking, Amira? 2. I like it. That's what I was thinking as well. So I'm going to divide the top by 2 and the bottom by 2. And 12 divided by 2 is 6. 40 divided by 2 is 20. Still have to go to lowest terms. What can I divide by again? 2 again. And I did that on purpose. Some of you thought, oh, we could do better than 2, I bet. 6 divided by 2 is 3. 20 divided by 2 is 10. That's in lowest terms. What could I have divided by? I could have divided by 4. And I'm going to show that. 12 over 40 divided by 4 divided by 4. 12 divided by 4 is 3. 40 divided by 4 is 10. You always get the same answer. This took 2 steps. It's fine. But if you could find a bigger number that goes into it, do that because it's just fewer steps. If you can divide 2 into it, try 4 as well. Try 6. You can use your calculator for that if you're not sure. Just do 12 divided by 4. Do you get a whole number? If you get a decimal, no. No decimals inside fractions. 40 divided by 4. Oh, yeah, that's 10. Okay, 4 works. Try 6. Try 8. Try 10. Right? See if there's something bigger. Don't spend a ton of time doing it. But you could try a few numbers like that. If 2 doesn't work, no multiples of 2 will work. 4 won't work, 6 won't work, 8 won't work, 10 won't work. Right? So that's how you reduce to lowest terms. That's the final answer that we want. Always reduce to lowest terms. Any questions about that? Notice that I divided by 2 here, and I've divided by 2 here. And 2 times 2 is 4. Not a coincidence, right? That's how that relationship works. That will always happen. I think it's a good idea, at least for now, to do that, but down the road you won't have to know. Okay, next one. How do I multiply a fraction by a whole number? We kind of talked about this the other day. Yesterday when we talked. Yep, go ahead. No. I think I know what you're thinking, but it's not quite right. What do you think? Right, we talked about this yesterday where this is actually, so I'm going to write an extra step. This is 5 over 1. So you have to know that. Multiplying a fraction by a whole number is something you're going to do a ton of in this course. So remember that whole numbers are always over 1. 6 times 5, 30. 7 times 1, 7. And that one's already in lowest terms, so we're done. Again, you should write this for now, but down the road, you could just do 5 times 6 is 30 and 30 over 7. The denominator doesn't change. Don't do 5 times 6 and 5 times 7. Don't do that. That's an easy mistake to make. Next question. 2 2/3 times 1/2. So this is where we have to convert the mixed fraction to an improper fraction before we multiply. Our first step is always going to be to get rid of mixed fractions. How do we do it? We talked about this the other day, but I'm just going to go over the rule. It's 2 times 3 plus 2 over the same denominator. The denominator doesn't change. So 2 times 3 is 6. 6 plus 2 is 8. It's 8 over 3 times 1 over 2. I'm going to write that off to the side if you want to as well, so you remember. So 2 times 3 plus 2 over 3 times, then add. Now I just multiply straight across. 8 times 1 is 8. 3 times 2 is 6. Can I divide something into both of them? Too often, right? So divide by 2, divide by 2, and then you get 4 over 3. This almost looks like the same question, doesn't it? Huh? Except it's got negatives. Watch carefully. This is the mistake that people are going to make. I'm going to go down here where I have some empty space. So just watch for a minute. This is what people do. Negative 2 times 3 is negative 6. Negative 6 plus 2 is negative 4. So is it negative 4 over 3? Because if you were multiplying negatives, that's how that would work. If this is 0, and this is 1, and this is 2, and this is 3, 2 2/3 is 2 2/3 of the way to 3. So this is 2 2/3. Negative 1, negative 2, negative 3. So negative 2 2/3 should be in the same place of the number line, but on the other side of 0. Negative 4 over 3 is here. So this is wrong. Does that make sense? So listen carefully. When you're converting, this is like the most important thing about this lesson. When you're converting a mixed fraction to an improper fraction, you ignore the negative. So this is 2 times 3 is 6. 6 plus 2 is 8. It's negative 8 over 3. The negative just hangs out front. It has nothing to do with converting to a mixed fraction. Times negative 1/2. Does that make sense? Everybody get that? Really important. It's such a common mistake. 2 negatives makes a positive. This works out to 8 over 6 again, which we already said was 4 over 3. Is everybody okay with that? I know I did that kind of quickly. We don't have a ton of time, but think about the number line. Negative 2 2/3, positive 2 2/3. This is just the negative of that. Negatives have nothing to do with converting a mixed fraction. That's what you need to know. What if I'm multiplying 3 fractions? We talked about this before. Yes, you could do it the first 2 and do an answer, and then do the next ones and do it in steps. But I would say you could probably go straight across. 2 times 4 is 8. 8 times 5 is 40. So, and I've got one negative, positive, negative, positive. So my answer is going to be negative 40 over. So this part's going to be a bit harder. 5 times 7, 35. 35 times 4. What's that? This is where you can use your calculator if you need to. It is 140. What can I obviously divide both of these by? 140, I don't think I can divide by 40. That's a good guess, though. It looks like you could. I wouldn't be surprised if you would try that. Haley? 10. I like that one because they both end in 0. So obviously you can divide them both by 10. And that gives you negative 4 over 14. You just lose the zeros. I don't even have to think about that to do it. And then what can you divide by again? 2. And you get negative 2 over 7, and that's in lowest terms. We got one more to do, and it's going to be an important one. We're running out of time, but this is a really important one. There's a trick when you're multiplying fractions. Most of you have probably seen it. You don't have to know it, but it's really useful. So I would encourage you to explore using it and try using it. 12 times 25 is pretty big. I could do it if I had to in my head, but it would be a lot harder. When we start to get in these big numbers, they get harder. Folks, listen carefully. This only works when you're multiplying. We don't do it when we're dividing. We don't do it, like sort of, but we'll talk more about that on Tuesday. We definitely don't do it when we're adding and subtracting. But when I'm multiplying, when it's all multiplying, what's the other way we can think about a fraction? 12 over 5 is 12 divided by 5. But I can actually divide across a multiplication symbol. So what is 25 divided by 5? So I'm dividing 5 out of both of these, and I'm left with 5 here and 1 there. And 12 divided by 6, I get a 2 here and a 1 here. And you don't have to write the step, but I've reduced this question to 2 over 1 times 5 over 1, which is 2 times 5 is 10, 1 times 1 is 1, 10 over 1 or 10. If you get a question over 1, it's better to even write it as a whole number. Why not, right? How easy was that math to do in your head when you could cross out? Super easy. I didn't need my calculator. The numbers got smaller. I want you to watch. I know we're about to run out of time. I'm going to make up one more question. And you don't even have to write it down, but I want you to watch because there's a quirk to this. Oh, and the other thing, if you do this correctly, you'll never have to reduce lowest terms. That's kind of nice. Don't pack up yet. We're not done. I need you to watch. I need your attention. Listen carefully. Oh, that's not what I wanted. I want 8 over here, 1 and 5. There we go. I can't divide 12 by 8. What can I divide into both 12 and 8? 4. So if I do that, 12 divided by 4 is 3. 8 divided by 4 is 2. Is 2. And that's how you cancel when you can't divide all the way. But you divide, it's kind of like the opposite of lowest terms, or it's kind of, I guess, like lowest terms. What can I divide into both? So then I get 3 over 5. Hold on, times 1 over 2. 3 times 1 is 3. 5 times 2 is 10, and you're done. Okay, now you're good. Now you're done.